Do you have a balanced diet? This is very difficult to determine, as it is very complex to find out. A balanced diet contains the right amount of carbohydrates, fats, proteins, vitamins, minerals, water, and dietary fiber to make the daily requirements of the body. Every one of us requires different nutrients, and this depends on our lifestyle, activities, and age. This is why a balanced diet for one person may not be a balanced diet for another. Balanced diet provides the energy to survive and stay healthy. Energy is needed to do work while we are awake and to perform activities when we are at rest or asleep. The amount of energy needed to carry on vital processes of the body when it is in complete rest is known as basal metabolism, where metabolism is the chemical reactions that take place within our bodies. The basal metabolic rate is a measure of how fast chemical reactions are occurring when a person is completely at rest. For example, the energy required in the beating of the heart. Basal metabolic rate is affected by climate, body size, age, sex, and health of an individual. Climate. A person living in a cold country tends to lose more heat in his surroundings and uses more energy in order to maintain his body temperature. Thus, his basal metabolic rate is higher than that of a person living in the tropics. Body size. People of the same sex and age may have different body size and weights. It is estimated that those with a bigger build require more energy than those with a smaller build. Age. Growing children normally have a higher basal metabolic rate than older people because they require more energy for growth. In adults, the basal metabolic rate tends to decrease slowly throughout life. Sex. Men normally have a higher heat production than women of the same body size and age, which requires more energy, as men usually have a smaller amount of fatty tissue in their bodies. Thus, the prevention of heat loss is less efficient in men than in women. Health. The thyroid gland in the neck controls the metabolic rate by secreting a hormone called thyroxine. If someone has an underactive thyroid, it results in insufficient thyroxine and thus lowering the metabolic rate. Overactive thyroid produces more thyroxine, resulting in a higher metabolic rate. Activity. If someone is very active and does heavy work, he or she needs more energy per day than a person who is moderately active. Role of dietary fiber in our diets. Dietary fiber refers to the indigestible fibrous materials in our diets. A good example of this is cellulose that is present in fruits and vegetables. These fibrous materials are important because it provides bulk to the intestinal contents and helps peristalsis. Peristalsis is the contraction and relaxation of muscle on the walls of the digestive tract. Such movements enable food to be mixed with the digestive juices and at the same time move along the digestive canal. With the whole process going so smoothly, it may make you wonder how constipation occurs. Constipation can occur if peristaltic muscles do not move properly. The undigested matter in the large intestine cannot be moved along fast enough, causing an excessive amount of water to be absorbed. As a result, the feces become dry and hard, and the feces removal through excretion becomes difficult. Constipation can be prevented by taking enough fiber and consuming sufficient water. Fresh fruits and vegetables, bran, cereals, whole wheat flatbread, and breads are good sources of fibers. Carbohydrates and its types. We encounter many types of carbohydrates in our daily lives, from bread to rice, and even to cellulose in our clothes. Carbohydrates mainly come from plants and are a good source of energy for the body. They also function as supporting structures, like, for example, cellulose cell walls in plants. They are used to make other organic compounds like amino acids and fats. Nucleic acids like DNA are also formed by carbohydrates, as well as lubricants like mucus. Another fascinating function of carbohydrates is that they are also used to produce the nectar in some flowers. Carbohydrates are organic compounds made up of carbon, hydrogen, and oxygen. The hydrogen and oxygen atoms are present in the same ratio, that is, 2:1. There are three main types of carbohydrates: monosaccharides, disaccharides, and polysaccharides. Monosaccharides have a simple chemical composition and therefore known as simple sugars. Examples of them are glucose, fructose, and galactose. The sugar glucose is one of the simplest forms of sugars and has the chemical formula C6H12O6. The generalized formula for carbohydrates is CnH2mOm. In the case of glucose, N and M is equal to 6. Disaccharides are also known as complex sugars, as they have complex chemical compositions. Maltose, lactose, and sucrose are their examples. Disaccharide structure molecules are made up of two molecules of simple sugars condensed together. The most common types of disaccharides have 12 carbon atoms, with the general formula C12H22O11. The differences in the disaccharides are again due to the different atomic arrangements within the molecule. Sucrose, or cane sugar, occurs in sugar cane stems, sweet fruits, and certain storage roots, for example, carrots. It consists of a glucose and a fructose molecule combined together. Lactose, also known as milk sugar, is commonly found in milk. As the name suggests, it is found in milk of all mammals, including humans, and even in some similar fluids, such as pigeon's milk. It is formed from glucose and galactose combined together. Maltose, known as malt sugar, is present in malted cereals and sprouting grains. It is formed from the partial digestion of starch and is a combination of two glucose molecules. As mentioned before, the formulation of one molecule of disaccharide requires two molecules of simple sugars. Each reaction is known as condensation reaction. Condensation is a chemical reaction whereby two simple molecules are joined together to form a larger molecule with the removal of one molecule of water. On the other hand, when a disaccharide is treated with a suitable enzyme, it breaks down to form monosaccharides. In this reaction, water is added, and thus the reaction is called hydrolysis or hydrolytic reaction. Polysaccharides are the most chemically complex carbohydrate, and its examples include starch and cellulose. There are other substances which are slightly modified carbohydrates, such as the chitin of the arthropod skeleton. What are fats? You may want to get rid of your extra fat because you may think that fats are useless in our body. But the case is otherwise. It is good to get rid of your extra fat, but fat in normal quantities is beneficial for the human body. In fact, not only in humans, but also other mammals like whales. Today, we will find out how fats play a crucial role in the bodies of humans and other mammals. Like carbohydrates, fats are energy-providing foods and are commonly used as food stores, especially by animals. Fats are composed of carbon, hydrogen, and oxygen. But unlike carbohydrates, fats contain much less oxygen in proportion to hydrogen. Fats can be split into simpler compounds by hydrolysis. When they are hydrolyzed, they yield fatty acids and glycerol. Fats and oils. We call coconut oil an oil, but when we place it in a refrigerator, it soon hardens into a mass of fat. Thus, the difference between fats and oils lies in their state. Fats are solid and oils are liquid at 20 degrees C or room temperature. Here, we shall use the term fat to refer to both solid and liquid animal and vegetable fats. Fats have many functions in the body. To start with, it is an efficient source of storage of energy. It acts as an insulating material present beneath the skin to prevent heat loss. In mammals that live in water, there is a greater tendency to lose heat. Therefore, animals such as whales have a thick layer of blubber beneath the skin, which helps to hold body heat. Sex hormones and other related hormones are made of fats. One of the main compositions of the partially permeable membrane are also fats, which is why the membranes are also called the lipid bilayer. Fats can be classified into two types, saturated and unsaturated fats. The types of fats occurring in animal bodies are called saturated fats. Usually found together with saturated fats is a fatty substance called cholesterol. Cholesterol may get deposited on the inside lining of the arteries and form a plaque. This may cause a heart attack. Fats should also be avoided in the diet of people who have developed gallstones in their gallbladders. Vegetable fats are unsaturated fats. They do not cause heart disease. Therefore, they can be substitutes for animal fats as often as possible. How can I include fats in my diet? Fats can be included in our diets by eating foods like butter, cheese, fatty meat, olives, many nuts and seeds of castor oil, palm oil, and many leguminous plants. Fats are also abundant in the liver of many fish, for example sharks. Humans and other mammals can manufacture their own fat requirements. Thus, fat is not essential in the diet. Vitamins. Deficiency diseases such as scurvy and beriberi are caused by the lack of certain chemical substances in our diet known as vitamins. Vitamins are organic compounds that are not built in a definite pattern like carbohydrates, proteins, and fats. They are not energy-providing foods nor bodybuilding foods. Yet, they are required in small quantities by animals, including humans, for normal health and development. In both underdeveloped countries and developed countries, a deficiency of vitamins can arise. How, you ask? In developed countries, people eat processed foods more, and thus, vitamin-rich raw fruits and vegetables are avoided. In underdeveloped countries, people do not get a balanced diet, and so are malnourished, resulting in vitamin deficiency. Vitamins can be grouped into two types: fat-soluble and water-soluble. Fat-soluble vitamins, as the name suggests, are soluble in fats and can be stored in the fats of the body. But water-soluble vitamins cannot be stored in the body and need to be supplied in the daily diet. When a particular vitamin is deficient, characteristic symptoms appear. Usually, a mild vitamin deficiency is hard to detect, but it may impair a person's well-being, so he feels run down or irritable. If the deficiency is severe, the particular deficiency disease will develop. As vitamin supplements are becoming easily available over the counter, we must take precaution of the dosage while consuming them. Larger quantities of some vitamins are toxic and may produce mild diseases and should only be taken when prescribed. Source and functions of vitamins. Vitamin A. Ever heard carrots are good for our eyes? How is that? Carrots are a rich source of vitamin A fat-soluble vitamin, and is required for the formation of a light-sensitive pigment in the retina and for maintaining healthy epithelial tissues. Rich sources of these vitamins include dairy products, fish liver oils, and green leafy vegetables. Vitamin B complex. Vitamin B has many subtypes, many of which are important coenzymes in cellular respiration. Beriberi and anemia are deficiency diseases caused by a lack of certain B vitamins. Yeast, liver, and bran are rich sources of the vitamin. Vitamin C, or ascorbic acid. It is a water-soluble vitamin. Vitamin C is needed for the synthesis of intercellular substances. The substances are found between the cells, and they keep the cells together. Vitamin C is also necessary for maintaining healthy epithelial tissues. It is, however, not effective against influenza according to popular belief. The richest sources of this vitamin are fresh citrus fruits like oranges and lemons, and some other fruits like papaya, guava, tomatoes, and bananas. Vitamin C is also found in fresh green vegetables. Fruit juices such as blackcurrant juice and rosehip syrup are often used as convenient sources of this vitamin. Vitamin D. Vitamin D is a fat-soluble vitamin. It promotes the absorption of calcium and phosphorus compounds from the intestines. It also allows the body to use these compounds in the formation of bones and teeth. It is found in fish liver oils like cod and halibut, egg yolk, milk, and margarine. Ultraviolet rays in sunlight can convert a natural substance in the skin to vitamin D. So if a person gets enough sunlight, vitamin D is not needed in the diet. Proteins. From the meat we eat to our enzyme and the histone molecules that wind our DNA together, all of them are proteins. Like carbohydrates and fats, proteins are also very complex organic substances containing carbon, hydrogen, oxygen, and additional elements, nitrogen. Sulfur and phosphorus may also be present. Protein molecules are the largest and most complicated of all the food substances. Every protein molecule is built up from simpler compounds known as amino acids, the basic units of proteins. Most of the amino acids have a common structure consisting of an amino group, an acidic group, and hydrocarbon side chain denoted by R in this way. R varies depending on the type of amino acid. R may sometimes be sulfur, carboxylic acid, amino group, or hydroxyl groups. Naturally, there are 22 amino acids in plant and animal proteins. These are combined in various ways to form various different protein molecules. This is analogous to English language that has only 26 alphabets but forms many different words. When two amino acids link up, there is a removal of one molecule of water that is called a condensation reaction. The bond formed between these two amino acids is strong and known as the peptide bond. If three or more amino acids are linked up by peptide bonds, the polypeptide or peptone is formed. Polypeptide in turn may be linked up to form a very long chain of amino acids. An amino acid chain can contain about 500 units on average. A protein molecule is made up of one or more such chains. The amino acid chains in a protein molecule are not arranged structurally straight. In most proteins, the chains are coiled up to give the protein a three-dimensional distinctive shape and are held in place by weak hydrogen bonds. These bonds are easily broken by heat, acids, and alkalis. The breaking of these bonds causes protein denaturation and affects the functions of protein. This is why when we have a high fever, we are told to lower our temperature. As protein molecules are very large, they cannot pass through cell membranes, so the ingested proteins cannot be absorbed directly into the body of animals. They have to be broken down by enzymes. Digestion is another example of hydrolysis. The proteins are first split into polypeptides, which are in turn split into their constituent amino acids. Since amino acids are soluble in water and small enough to diffuse through living membranes, they can easily be absorbed into the body. When amino acids enter the body cells, they are linked up again to form the required protein. An average kid needs approximately 18 grams of protein a day. The deficiency of proteins in the diet of children may lead to a protein deficiency disease called kwashiorkor. Such children usually have swollen abdomens and scaly skin with cracks. Proteins play numerous important functions in our bodies. They act on growth and repair of cells and cell organelles, composition of enzymes and some hormones, formation of antibodies, and of course, they are also a source of energy.
Thank you for your continuous support, especially our valued patrons and members who have been encouraging us to keep producing more quality content.